Hello, this is part 2 of special products of binomials, and as a review, I want you to try these two exercises on your own using the shortcut. You can use FOIL to check your work, but I want you to use the shortcut. So hit pause, work on these two problems, and then hit play again to see the answers. The answer to this one using the shortcut is the first term squared. The last term is also squared, so 9 squared is 81. And the middle term is x times 9, which is 9x, times 2, which is 18x. And there's your answer. This binomial here, we do the same thing. So let's do the shortcut. We're going to take the first term and square it. Now be careful. When we square 3x to the second power, that is equivalent to 3 to the second power and x to the second power. So 3 to the second power is 9 and x to the second power is x squared. So be careful. This 2 we distribute to each one of the exponents, okay? So it would be 3 to the second power, x to the second power, 9x squared. So we did the first term squared. The last term is this second term squared. Again, 2y squared is the same thing as distributing this 2 to each one of the exponents, okay? So 2 squared times y squared, which is 4y squared. So that means that the last term is 4y squared. The middle term we said is this first term times the second term times 2. So let's do that. It's going to be 3x times 2y times 2. So 3 times 2 is 6, times 2 is 12, and x times y is xy. And this is our middle term, 12xy. So this is what you should have gotten, okay? If you're still doubtful, do the practice problems in your book. Let's do one more of these, just to make sure that you got it. Let's say we want to multiply. That means that this is the same thing as 5x plus 3y times 5x plus 3y. They are twins. That means I can use the shortcut. So let's do that. It's the first term squared. So let's go off to the side. 5x squared. The whole thing, that means 5 squared, x squared. So that equals 5 squared, x squared, which is 25x squared. So that's your first term, 25x squared. We squared the 5 and we squared the x. Plus, the last term is this second term squared. So 3 squared y squared. If you want to go off to the side, you can do that. You distribute the 2 to each one of the terms inside. This would be 3 squared y squared, which is 9y squared. So it's basically squaring the 3 to get a 9 and squaring the y to get a y squared. And then the middle term we said is the first term times the second term times 2. So let's write that. It's 5x times 3y times 2. And that means 5 times 3 is 15, times 2 is 30, and x times y is xy. So that's your middle term, 30xy. Okay? Excellent. Now, let's talk about these kinds of special products. We're going to talk about having, for example, x minus 3 times x minus 3, or x minus 3 squared, which is basically the same exact thing. Now, let's do FOIL so that you can see a pattern. When I do FOIL, x times x, x squared. And then I do x times negative 3. Be careful with this minus. This is x times negative 3, so that would give you negative 3x. And then we do inner. negative 3 times x. That gives you negative 3x again. And then we do negative 3, the last, with the last, which is negative 3, times negative 3, which is positive 9. Negative times negative is positive. When we collect like terms, we get x squared minus 6x's plus 9. A big mistake students make with the negatives. They will subtract. And when you have the same sign, we add and we keep the sign. Okay, so be careful. This is the result. If it helps you, you can change this minus to plus negative and change this minus to plus negative if that helps you. I'm going to go ahead and do this exercise again, but changing that minus to plus negative so that you see that, let me change that, so that you can see this other possibility, okay? So if you have this, you can change this to plus negative and plus negative, and then start multiplying. First, that gives you x squared. Outer, which is that, times the outer one is negative 3x, right? Or you can write plus negative 3x. And then the inner, which is negative 3 times x, you can write plus negative 3x. And then you have negative 3 times negative 3, and that makes a positive 9 because negative times negative is 9. And then you'll have x squared plus negative 3 plus negative 3, that makes negative 6x plus 9. These two results are identical. These two are identical, okay? Writing minus 6x or plus negative 6x is the same exact thing. But the important thing I want you to notice here is the pattern. Notice that the first term is the square of the first term. Let's write it over here. X minus 3 squared. The first term is the square of the first term. The last term is also the square of the last term, but it's positive, okay? Because negative times negative, that means negative 3 squared is negative 3 times negative 3, which is positive 9. That's why this is plus 9. Now when we do x times 3 times 2 for the middle term, we get negative because it's x times negative 3, which is negative 3x, times 2 is negative 6x. So the pattern is when we have a minus and they're twins, I need to do the same thing I do when I have a plus, except that the middle term will always be negative. Always, okay? So let's try a couple. Let's say, let me scroll a little bit. Let's say I give you x minus 5 squared. Without doing FOIL, let's use the shortcut. We said it's the first term squared, so x squared. We said that the last term is positive because negative times negative is positive, so this would be 5 squared, which is 25. And we also said the middle term is going to be minus, or you can write plus negative. I like to write minus. So x times negative 5, negative 5x, times 2, negative 10x, so minus 10x. And like I said, you can also write plus negative. It's exactly the same result, okay? Try these on your own. I want you to do x minus 8 squared. Give me an answer for that. And also, I want you to do 3x minus 4y squared. So hit pause, work on these two problems, and then come back for the answer. Using the shortcut for this one, you get x squared minus 16x's plus 64. And for this one, using the same shortcut, the first term square, that means 3 squared, which is 9, x squared, which is x squared, The middle term is always a minus, but it comes from multiplying 3x times 4y times 2. So let me write that 3x times negative 4y times 2. That gives you a total of negative 24xy. And then the last term we said is always positive, which is 4y squared, which is squaring 4, that gives you 16, and squaring y, which gives you y squared. And here is the answer for this one and the answer for this one. It's pretty simple once you learn the rules and you learn how to recognize the patterns. Sorry about this. Okay, there you have it. Let's do one more example before we leave. Let's try 6a minus 1 squared. I'm going to give you a couple of minutes to work on it and then come back to see if you got the right solution. So hit pause. The answer to this is square the first term, so that's 6 squared, which is 36, a squared, which is a squared. The middle term is a minus, and I know it's this times 2. So 6a times negative 1, negative 6a, times 2, negative 12a. So minus 12a is the same thing as negative 12a. And then the last term we said will be a plus, and negative 1 times negative 1 is positive 1. So there is a solution. Try this one, 3 minus x squared. Hit pause and come back for the answer. The answer for this one is the first term squared, which is 3 squared, that would be 9. The middle term is a minus, and it comes from multiplying first term times second term times 2. So 3 times negative x squared, negative 3x squared, times 2, negative 6x squared. And then the last term is positive, and we're going to square x squared. So when we square x squared, that means we're raising x squared to the second power. That means we're raising a power to a power, and this was one of our exponent rules. We said that when we raise an exponent to a power, the property says to multiply the exponents. So this becomes x to the power of 2 times 2, which is 4. It's not adding, it's multiplying, okay? So that means that our last term will be x to the 4th power. And it makes sense because if you have x squared squared, what we're really doing is multiplying x squared times x squared. And now we use the exponent rule that says that when we multiply the same base, we can add exponents, and that would be x to the 4th power. So, but we don't have to do this. We just learn this rule, and whenever we have a power raised to a power, we multiply the exponents, and we get the same answer as if we did it the long way. Okay, so this would be the answer to that one. I hope you understood these examples, and good luck on this section. I'll see you